Ladies and gentlemen, good morning. My name is Herman Cznewajs, and it's my honor to present you outputs of challenge number 11, automatization of calculation of management zones based on yield potential. I will show you the content of the video. Firstly, we will say what was the motivation or what was the problem we were trying to solve. Then what is our vision or our solution for that problem. And then we will go through solutions step by step. We will find the input data, and then I will show you how our output tool works. So what was the real challenge for us? The main challenge are the fertilizer prices. It is not only current topic, it is long-term, and it is clear that the trend will trend to decrease the fertilizer use will continue in the future. Also, the European Green Deal is planned for many decades, and one of its part also wants less fertilizers to be used. All national and EU subsidies also support ecological farming and environment-friendly approach. So it is clear that we shall use fertilizers as efficient as possible. I also heard about some farmers that due to the fertilizer price increase, do not use fertilizers on conventional fields, but it leads to significantly low yields. So what the challenge was to answer on question, what shall we do with the fertilizers? Or how shall we use them? We see the future in individual zone approach. It is opposite to uniform rate application, and it's based on the fact that the field is usually not uniformed, but there are some zones which needs more fertilizer because there is more vegetation, and then some zones where there is lower potential for crop growth, so not so many fertilizers has to be used there. And unfortunately, uniform fertilizer rate is traditionally applied, even when it doesn't help in some parts in the field, and there is too much fertilizer, which then goes into rivers and lakes. And so we said, let's try to do it in a clever way and apply the fertilizers in those places where it helps and saves some money, and where the crop doesn't need it, we don't have to put much fertilizer. I love that this solution is both economically meaningful and environment friendly. So the main thing we have to do is to find the variability in the field which corresponds with the need of fertilizers. So as we said, one input should be some data which will show us some heterogeneity in the field. And we think satellite data offer us exactly what we need. The data are free, there is good spatial resolution, and there is sufficient revisit time. And the images from satellites are large, so we usually process one image, and there are all fields of the farm. There are more alternatives, which images to use. We, in this challenge, used ESA's Sentinel satellites, which are the most advanced, but there are also satellites from NASA, which are also fine. Then we need to analyze the images to get the right information. We calculate so-called vegetation indices, which tell us how much vegetation is on any place in the farm. And when we focus on one field, we see that there is heterogeneity in the field, that not all the areas in the field are of the same values. There are some fields where there is more vegetation and some fields where there is less. It can be of various reasons. For example, some mice eat the seeds, and it tells us that there is no need to put the fertilizer in those places. Or the agronomist should know the reason, and he can just decide what strategy he will apply. Yeah, there are dozens of vegetation indices. There are moisture indices as well, and some are more general, some are more specific, used in a certain situation. And to understand the indices and to help the farmers and the researchers use them and understand them, we created a web page about them. It is a part of Hub for Everybody, and Hub for Everybody was created in Agrihub Hackathon as challenge number 6. So that was mutually beneficial cooperation. We can try to see how does the page look like. Yeah, there is some explanation what does the index is about, how is it calculated, and in some satellite systems there are some references to literature, and there is also example how does the index look on farm. So that's it. There are few indices, but more will be added soon. And now we are getting to the second input, and it is field borders. There are again more possibilities how to get them. The best and easiest way is when the farm has its own database of the fields and crops. However, it is not very usual. Most of the farmers don't have them. And so that the second option is a national database of land parcels. This database is open and it is up to date. However, in this database, often more fields with different crops are merged to one land parcel, and it makes correct in-field analysis impossible because we have to have borders of every crop, not to mix more crops in one field. And yeah, our idea is to improve the public border database by classification of satellite data. From satellite time series, the algorithm is able to distinguish crops and then create a border between them. So the process is not fully automated yet, but we tried this process could work. We see in this picture the unsupervised classification. Then the classification was vectorized, and here is a comparison of this layer and data from the farmer. So we see, or it is, yeah, we see the most of the lines corresponds. And when we have borders and input data, we are ready to do the calculations. A Python script was created to divide the fields into the zones. And also some basic interface was developed during the hackathon to enable testing the tool. Although the tool is still in some prototype version, it is public and anyone can try it out. This should be the outcome. There is a field and it is divided in zones which tell the farmer which places are better than the another, and the farmer can decide where he will put more fertilizer, right, and where less. And we can also give it a try. I hope everything will work, so we can switch to English, and we have to zoom in, and now we have to wait a few moments because the database is loading. Now we can just select fields. We want one or more fields. We want to calculate the zones. So, for example, those three. We say how many zones we want to on the output, how it should be smoothed, and then which index, then we get dates, and then we can find which day we want to calculate, or from which day the satellite image is from, and then we just get the zones and we'll see. Yeah, and we see the result. And it says which areas are better than the another. We also might want to change the output zones number or amount. And yeah, now we have 5 classes. And now farmer can arrange the variable rate. The next step is to download the data and put it into machine. And well, this application is for testing, so there is no download option, but it was integrated as a part of challenge 1. It was integrated to a farmer's application, farming site, and there is possibility to download the zones, and then a farmer can put it into the machine. And yeah, the great thing about this tool is that we can have just a current image. This image is few days old, so it is perfect that we can have really up-to-date data. And that's all from me. Thank you for listening me. Thank to all the participants of the hackathon, and especially thanks to our amazing team for the great job we have done together.